Hello and welcome to this oral presentation. I'm Elena Babatsui. I am affiliated with the Department of Communicative Disorders at the University of Louisiana at Lafayette. The title of my presentation today is The Development of the Voiced Velar Fricative in Greek. Fricatives and velars are represented in child phonological acquisition cross-linguistically, but little is known on how the voiced velar fricative develops, especially in clusters. This is the focus of today's talk. The voiced velar fricative is represented phonemically in several languages like Arabic, Dutch, Hebrew, Hungarian, Polish, etc. In some languages, it has an allophonic use for targeted velars, like the voiced plosive in Basque, German, Japanese, and Spanish, but also for the voiceless fricative in Czech and for the rhotic in Portuguese. In fewer languages, the voiced velar fricative forms a consonant cluster, as for instance, the word medial gd in Hebrew and the word medial gz in Polish. The distribution of Greek singleton or cluster rules 5% in the first 1,000 most common words in Greek, as shown in this slide. The sound appears in function words, nouns, adjectives, and verbs. To read the first line of this word list, ego, meaning I, ligo, some, pragmata, things, signomi, I'm sorry, grigora, quickly, stigmi, moment, pragma, thing. There are 7 two-member clusters in Greek that involve the voiced velar fricative, and these are not commonly found in other languages. These clusters are only permitted in word initial and word medial position in Greek. In 4 of them, the fricative pairs in first member position with the liquids, the tap and the lateral, in first member position with the alveolar nasal plosive and with the voiced interdental fricative. Lastly, in 2 clusters, V is a second member in sequences with fricatives, the alveolar sibilant Z and the labiodental V. Among these cluster types, sequences with liquids are more frequent in the language, with the rhotic cluster being more frequent than the one involving the lateral, while sequences with the interdental and the voiced alveolar are rare. In terms of the sonority sequencing principle, all Greek clusters with the voiced velar fricative rise in sonority, except those involving another fricative, thus having level sonority. The sonority sequencing principle is commonly employed to understanding consonant cluster acquisition and cluster reduction patterns. Rising and large sonority distance are generally found to be least marked in acquisition, though not without exceptions. In terms of reduction patterns, the more sonorant member is reduced. In clusters with level sonority, place is a more important factor than sonority in determining which member gets reduced. Greenlee in 1974 identified 3 stages in cluster acquisition: reduction to a single element, 2-element production involving substitutions, and correct productions. These stages have been verified subsequently. Babatsuli and Sotiropoulos expanded the categorization of these stages into 9 types to differentiate omission from reduction and correct from substituted patterns in productions, including vowel epenthesis. We turn next to the acquisition of the Greek voiced velar fricative. As singleton, it is acquired between ages 2-6 and 3 years and 6 months at word initial position, and between 3 and 4 at word initial position, and between 3 and 4 at word medial position. The phoneme is not permitted word finally. The 2-member clusters with this velar are acquired late by monolingual Greek children. The norms presented here are from PAL 1995, the Pan-Hellenic Association of Logopedics, and from a study by Papadopoulou 2000. Those sequences with liquids are acquired after age 5 and by age 5-6, while the sequences with labial and alveolar fricatives are acquired between 6 and 4 in the first case and between 4, 6, and 5 in the second case. There are no data for the acquisition of sequences with the nasal, gnu, and with the interdental fricative, gd. However, the voiceless velar fricative cluster with the nasal hnu is acquired between 4, 6, and 5, according to Pal, 1995. The goal of the present study is to investigate the longitudinal development of Greek clusters with ru in a child's speech in terms of reduction and substitution patterns, and what this can tell us about the acquisition of the sound. This is a case study of a girl's phonological development in Greek longitudinally from age 2 years and 7 months to 4 years. The data come from spontaneous speech and are transcribed in IPA in a CLAN database of 511 chat files. There is a 90% inter-rater agreement on transcription reliability. Pratt was also employed to check the reliability of transcription. There are 70 targeted voiced velar fricatives in this dataset. As a singleton, ru is produced correctly at only 5% at age 2-7, the beginning of the study. It starts progressing after age 3-5, quickly reaching 60% at 3 years and 7 months and 90% at 3-8. The main developmental substitutions of ru are the lateral, the palatal fricative, which is an allophone of the targeted sound in complementary distribution, the labiodental fricative, most often by assimilation, the interdental fricative, the palatal plosive, and deletions. The voiceless velar fricative, h, or the child substitutions for that, s, or the velar plosives, voiceless and voiced, do not substitute the voiced velar fricative in this child's speech as reported in other monolingual Greek-speaking children. The reason for that is that this child acquires velars as late as at ages 3-6 and 3-7, as shown in this example where the word ligo, meaning some, is produced as lijo. By contrast, at age 3-8, when produced as cluster member, the voiced velar fricative is accurately produced at 50%. In terms of reductions at the age of 3-8, the cluster with nasal is reduced at 100%, that with the tap, 75%, and with the lateral, 33%. The only cluster without reductions is that with the labiodental. When the clusters are reduced, what stays is singleton that is either produced as the targeted member, as in the labiodental v in vugalo, or as a substitution, like the lateral substituting the rhotic in gramma, produced as lama. Looking at the acquisition level of the cluster members, the voiced velar fricative, the rhotic, and the interdental reach about 65% accuracy at age 3-7 and over 80% a month later, though the other fricatives, the lateral and alveolar nasal, are acquired as early as at the beginning of the study at 2 years and 7 months. The dominant substitution of the voiced velar fricative is the lateral, as in the word vgalis, produced as vlalis. This is also the substitution of the tap and the interdental in this child's speech. These substitutions are interesting for deciphering reduction patterns of the sequences with liquid. Which member is reduced in clusters gru and glu? They both result in a singleton lateral production. To answer the question, we search for evidence in target-like productions, as in the word zographisis, produced as graphisis, where the tap is shown clearly reduced early on at the start of the study. So the reduction is to the non-sonorant member. The palatal fricative, typically an allophone of ru in targeted speech, is a substitution here, as in, for instance, the words gatula, produced as yatula, and grigora, produced as yigola. Gatula meaning kitty and grigora meaning quickly. The alveolar plosive in the production titola also shows evidence of reduction to the non-sonorant. It is worth pointing out that when the child acquires the tap at 3-8, the cluster with rhotic is occasionally reduced to it rather than to the obstruent, which is counter-evidence to the sonority-based argument. Reduction to the liquid has been reported before in the literature, as for instance in the acquisition of Valley-Zapotec word initial clusters in 6 children aged 1-8 to 2-11. Another substitution of the voiced velar fricative is the labiodental fricative V. An example word is the word glistrai, produced as vistai at 3-7. It means it is slippery. When we look at the reductions of the voiceless velar fricative with erotic, we see again that velar is retained over liquid, whether substituted or when produced as targeted. Here again, the overwhelming evidence is in favor of reduction to the non-sonorant. Now, what happens when the sonorant in the cluster is a nasal? This is the case for onset of no with alveolar and heterosyllabic gmu with labial. The reduction is to the sonorant nasal. The obstruent is actually deleted in this case. This may be explained by Barrow's implicational prediction for reductions in cluster acquisition, whereby if a segment of a given sonority is chosen instead of the fricative, then all segments of a lesser sonority will also be chosen instead of the fricative. For other explanations, clusters with unusual sonority are more likely to reduce the second member, and in heterosyllabic cluster acquisition, less sonorant consonants are preferred in the preceding coda. To sum, the nature of reductions is as follows. In rising sonority clusters, the obstruent is mostly retained if it is an oral segment, in agreement with other evidence in the literature. On the other hand, if the sonorant is a nasal, it is retained, the nasal is retained, providing evidence in support of Barrow's implicational hierarchy. In level sonority clusters, what is retained is the least marked place, in this case labial or coronal over velar. In terms of the acquisition level, the child sequence with the labiodental V is acquired as per norms at age 3-8. The clusters with liquid are acquired by the child before norms at 3-9 and 4, while for the other two clusters acquired after 3-9 and 4, there are no norms to compare with. Some concluding remarks: in reductions of rising sonority, the oral sonorant deletes, but the nasal sonorant is retained. In level sonority clusters, the least marked place is retained. In terms of acquisition level, the level sonority cluster with labial is acquired first, while that with the interdental is acquired last. Among the rising sonority ones, the sequence with the lateral is acquired before that with the nasal, which in turn are acquired before the sequence with the erotic. The child acquires these clusters earlier than per monolingual norms. This is a list of some references that I have used. Thank you very much for your interest.